Assalamualaikum and good morning everyone. My name is Muhammad Hafiz bin Rizal Shaini from Group 12.
My name is Muhammad Haris Mimza bin Abrazak from Group 2F.
My name is Muhammad Faiz Irshad bin Muhammad Isri from Group 12.
My name is Muhammad Idraki bin Imran and I am from Group 2F.
Today we will be presenting our project title, Development of a Solar-Powered Herb Drying Machine with a Mechanical Ventilation System under the supervision of IR Technologist Dr. Muhammad Zaid bin Akub. I will begin by explaining the introduction and objective, followed by our idea sketch and benchmarking. Herb drying is an important process to preserve quality, flavor and medicinal properties. However, traditional herb drying methods in Malaysia mostly rely on direct sunlight. These methods are often affected by unpredictable weather, long drying time and poor hygiene, such as exposure to dust, insects and moisture. Therefore, this project focuses on designing a direct solar power herb drying machine with mechanical ventilation. The aim is to improve drying efficiency, maintain product quality and ensure the system is suitable for Malaysia's hot and humid climate, especially for small-scale users. There are three main objectives of this project. First, to design an indirect solar power herb dryer that is suitable for Malaysia's climate. Second, to improve the drying process using mechanical ventilation so that the moist air can be removed more effectively. Third, to develop an environmentally friendly and energy efficient drying system that can be used by small-scale farmers and household users. This objective guides our design to be practical, sustainable and user-friendly.
I'm going to present to you our problem statement. So the first thing is the core problem that our project has to counterfeit is small-scale farmers usually face significant post-harvest losses and poor product quality due to unreliable and traditional method. So this undermines income for farmers, also the quality and supply for buyers, and medicinal potency from herb. And the next is the second thing that I'm going to tell you is the problem with the traditional method that we are using this day. So there's three problems that I must say to you. The first is unpredictable and containment. This means exposure to dust, insect, pests and erratic weather leads to contamination, mold growth and spoilage that will cause losses to farmers. And the poor quality control. Poor quality control mean that inconsistent temperature and humidity cause uneven dyeing, loss of volatile essential oils, color fading and nutrient degradation, reducing market value that also cause losses for farmers and also buyers. And the third one is slow and inefficient. Long drying time increase vulnerability to loss and limit processing capacity that limit the supply from farmers to buyers and make the quality poor. So the third thing is gap in existing solution. So there's gap in existing solution. While the basic solar dryer exists, many lack active mechanical ventilation. So as you can see in the market, there's already many solar dryer, but it lack active control mechanical ventilation. So our project is to counterfeit this, and this result in when many lack active and control mechanical ventilation, this result in a poor moisture removal in high humidity, stagnant air zones causing uneven drying, inability to optimize drying airflow independently of solar heat, limiting efficiency and control. So as you can see from this slide and from what I present to you, our product is going to be counterfeiting this three problems that we mentioned in our project. So thank you.
Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. I, Muhammad Idraki bin Imran, will take over from here and further elaborate on this project of ours, specifically speaking about solar-powered herb drying machine. As the slide shown on the screen, this page, it is talk about creativity of ideas. It is crucial for any project to involve outstanding amount of creativeness to improve a certain product's overall functions, assure the safety, and is eco-friendly. The first point I would like to emphasize on is the use of recycled materials. As stated, it will do a very good job on reducing its cost, therefore it is possible for farmers or anyone to afford without it having to cost a fortune, which will be a hassle. It also makes a good price for us students who are typically searching for cheap materials and could be a massive help for us, no offense, for the low given budget. Additionally, not only that it uses solar energy, but it is also made of environment-friendly materials, which are able to support the 3 Rs. That stands for reuse, reduce, and recycle, as well as reducing the need to use new materials, which will only be a waste. On top of that, the possibility of the machine being mobile. In this modern era, it is highly preferred for the most products to have an ability to be portable, where it could be brought to anywhere without causing much trouble. And to focus on this project, it will be a very much help. It will be a very much of a help if it has the possibility to be used in various places such as farms, homes, and most importantly, places that were just hit with disasters, where consumption are mostly necessary. And last but not least, the physical design itself. It is unnecessarily underrated of how most products, especially machines like this, do not get focused on its outer appearance, where it could potentially be a great opportunity to attract the non-engineers, thus inspiring them. With that, more ideas could be collected to further improve our life as human beings because of the birth of creative minds of young people at the first look at such wonderful design. It will be all from me for now. I would like to pass on my friend to continue our presentation. Hereby, I express my gratitude and see you later on.
This project focuses on the development of solar dryer as an efficient, low-cost, and environmentally friendly food drying system. The project scope covers 3 types of solar dryers, which are direct solar dryers that use sunlight directly, the indirect solar dryer that use heated air from solar panel, and mixed solar dryer that combine both sunlight and heated air to improve drying efficiencies. The target materials for this project include products such as ginger, pineapple, tea leaf, and salted fish. The preparation method is depending on the product, including slicing, using whole product, and applying pre-treatment when necessary. The drying quantity is set at 500 gram per session with a tray capacity of 1.5 kg per square meter. The application, the drying time depends on the moisture content of the material, especially for high moisture product like pineapple and mango. A low drying temperature is applied to prevent nutrition loss and product hardening, while a high airflow rate helps to prevent mold growth. From a design perspective, airflow is achieved either through the chimney effect or by using a DC vent powered by a solar panel. Material selection focus on durability and cost, using either metal or wood. Finally, the project considers economic and environmental aspects by ensuring low cost, high efficiency, and suitability for use in dusty and windy regions.
For our benchmarking, we studied existing solar dryer design in market. Benchmark reference 1 used indirect solar drying with a chimney effect to improve airflow. It has a simple structure, is portable and suitable for small farmers. However, the disadvantage include long drying time during cloudy or rainy days, limited drying capacity, and passive temperature control, which is not very precise. Benchmark reference 2 improved drain performance by using mechanical ventilation, powered by a solar fan. The designs allow faster drying, better moisture removal, and works well in high humidity conditions. However, the disadvantages are higher cost, more components require maintenance, and fan performance that depend on sunlight availability. For benchmark reference 3 features indirect solar heating, multiple trays, and an enclosed cabinet to protect herbs from dust, insects, and rain. This design provides more uniform drying and is suitable for Malaysia's humid environment. However, it is heavier, less portable, has high manufacturing costs, and still depends on weather conditions.
Hi, okay, so we'll meet again. On this slide, I will explain the quality of our concept design using a morphology chart. This chart helps us compare different design solutions based on key function of the solar power herb dryer. First, for the tray design, we consider 4 options: a drawer tray, a normal tray, a stack-up tray, and an extendable tray. This option allows flexibility in capacity, ease of loading, and airflow during the drying process. Next, for the solar panel and glass, we explore foldable solar panel, fixed solar glass, movable solar panels, and foldable solar glass. This option helps improve sunlight absorption while making the dryer portable and suitable for the different outdoor conditions. And for the outlet and fan system, we evaluate ventilation with an alarm sensor, exhaust fan, and a solar power fan. This ensures proper airflow, efficient moisture removal, and energy saving by using solar power. And lastly, for mobility and support, we compare normal wheels and wheels with an inlet and wheel and stand combination. This design improves stability and makes the dryer easy to move and use in different locations. Overall, this concept design is purposeful to address technical, economic, and user needs. Each design feature is carefully selected by us to improve drying efficiency, usability, and sustainability of the solar power herb dryer. So that's all from me. Thank you.
This table shows a comparison of 4 design concepts based on 6 design criteria, which are stackability, extendability, construction cost, portability, and ease of maintenance and capacity. Each design is evaluated using positive and negative indicators. Design 1 meet the requirement for stackability, ease of maintenance, and capacity, but it lacked extendability, portability, and low construction cost, giving a total score of 3. Design 2 performed well in terms of low construction cost, portability, and ease of maintenance, but it doesn't meet the criteria for stackability, extendability, and capacity, also resulting in a score of 3. Design 3 achieved positive result in stackability, low construction cost, ease of maintenance, and capacity, with only minor weaknesses in extendability and portability. This design obtained the highest net score of 4. Design 4 meet the criteria of stackability, extendability, and capacity, but has limitation in cost, portability, and maintenance, giving the score of 3. Overall, Design 3 is used as a guideline to develop new final design, as it satisfies most of the important criteria and provides a strong foundation for improvement and optimizing in the final design stage.
This slide shows the original idea sketch proposed by our team members. The sketch helps us visualize different design possibilities such as tray arrangement, airflow direction, solar panel placement, and ventilation layout. Through this sketch, we explore ideas like stackable trays, portable structures, and fan-assisted airflow to improve drying performance.
Here again I am to follow up and further present regarding this project. I will now explain the final design that we as a team chose, and the best construction in supporting to improve solar herb drying machine. First and foremost, I would like to go and describe its type. For this design, it is a mixed solar dryer, which has the features of both direct and indirect. The features I am referring to is, of course, by using the sunlight for both drying the product and also converting it to electricity to power up the fan. I will explain about the fan later on. Other than that, this design allows you to stack more trays, and it is expandable to enlarge the rooms in it, so you could store more products, thus drying them all at the same time. With this, it could greatly save time and remove the need to repeat the same process over and over again. Moreover, it has 2 modes, retracted mode and extended mode. In its retracted mode, it will consume only a small amount of space and make it easy to travel around with it, making it portable and easy to be brought around. In its second mode, it will allow the user to fully use it just like I explained earlier. Well, right now I would like to emphasize the fan as for my final point. The exhaust fan is a splendid choice when it comes to removing moist air to further improve the drying rate significantly. Additionally, it could also ensure uniform drying and result in a higher quality dry products. Alright, I think that's all from me. I hope that the information delivered was well enough. And my name is Muhammad Edward Kimemran, and I will appreciate to be excused. Thank you so much for this opportunity, and now I will pass it on my group member. Again, thank you for having me.